In question 10, a curve such that dy dx is 2x power minus half upon a plus ax power minus 3 upon 2, where a is a constant. The point a is a squared comma 3 lies on the curve. We have to find in terms of a in part 1 the equation of the tangent to the curve at a. Now to find the equation of the tangent, we need a point which is a squared minus 3 and the gradient. So the gradient is given by dy dx. The x coordinate at point A is given as x is equals to a squared. So we can substitute x is equals to a squared in place of x. So this will become 2 upon a squared into minus 1 upon 2 plus a into, so x is a squared into minus 3 upon 2. So a squared into minus 1 upon 2. So that will become 2 into, this will cancel out. So 2 into minus 1 upon 2 will become minus 1. Plus, and this 2 and 2 will cancel out, and this will become a into a to the power minus 3. So we can write this as 2 upon a squared, and this will become, so a into a minus 3 is a power minus 2. So a multiplied by a minus 3 will become a power minus 2, as this power is 1. So we can write this as 1 upon a squared. So this is dy dx is given by 2 upon a squared plus 1 upon a squared. We can simplify to write it as 3 upon a squared, as a squared is a common denominator. Now, once we have the gradient in terms of a, we can find the equation. The equation of a line is given by y minus y1 is equals to m into x minus x1. So the y1 coordinate at point A is given as 3. The gradient is 3 upon a squared into x minus the x1 coordinate, that is a squared. Simplifying, we'll get y minus 3 is equals to 3x upon a squared, and 3 upon a squared multiplied by a squared, that will become a minus 3. Now taking 3 on the right hand side, so this will become y is equals to 3x upon a squared minus 3 plus 3. So this will cancel out, and the equation of the tangent will be 3x upon a squared. In part 2, it says we have to find the equation of the curve, and that will also be in terms of a. Now to find the equation of the curve, we'll have to integrate the expression for dy dx. So the dy dx was given as 2 upon, so that was 2 upon a x to the power minus 1 upon 2 plus ax to the power minus 3 upon 2. Now to find the equation of the curve, we'll have to integrate the expression for dy dx. So that will become y is equals to, increasing the power minus half by 1, that will become plus half, and we'll have to divide by the new power in the denominator. Increasing minus 3 upon 2 by 1, so that will become minus 1 upon 2. So minus 3 upon 2 plus 1, so that will become minus 3 plus 2 upon 2, which is minus 1 upon 2. And we'll divide by the new power, which is minus 1 upon 2, and add a constant. Simplifying this, we can write it as y is equals to, so 2 will go in the numerator, it will become 4 x to the power half upon a. This will become minus, and this 2 will go in the numerator, so this will be 2ax to the power minus half plus c. Now once we have the expression, we can find the value of c by substituting the point a, as we have to find the equation of the curve. So we know that the point a lies on the curve, and it is a squared comma 3. So in place of y, we'll write 3. In place of x, we will have a squared upon a. This will become 2a. This will be a squared to the power minus half plus c. So this will cancel, a squared and 1 upon 2 will cancel out. And so that will become a upon a. So this will be 3 is equals to 4 minus 2. And again over here, so a squared to the power minus half, that will be equals to a power minus 1, and a multiplied by a minus 1 will be equals to 1. So this will be 3 is equals to 4 minus 2 plus c, which will be 3 minus 2 is equals to c. So the value of c will be equals to 1. We can now write the equation of the curve as y is equals to 4x to the power 1 upon 2 upon a minus 2a. We can write the x in the denominator as square root of x, and the value of c is plus 1. So this will be the equation of the curve in terms of a. In part 3, it says it is now given that B 16,8 also lies on the curve. We have to find the value of A using this value and find the distance AB. Now, as this point lies on the curve 16,8, so in place of x and y in the equation, we can write 16 and 8. So in place of, we know that the point B will be 16,8. So in place of y, we can write 8 is equals to 4 into 16 to the power half upon A minus 2a upon square root of 16 plus 1. So this will be 8 is equals to 4 into 4. That will become 16 upon a minus this will become 2a upon 4 plus 1. So taking the LCM over here, we'll get 16. The LCM will become 4a. And we can take the 1 on the left-hand side as well to simplify the equation. So that will be equals to 8 minus 1, that will become 7 is equals to 16. The LCM will be 4a up here. So this will multiply by 4. So this will multiply by 4 and this will multiply by a. So this will become 2a squared. Cross multiplying, we'll get 28a is equals to 16 times 4 is 64 minus 2a squared. Bringing the 2a squared and 64 on the right hand side, we'll get 2a squared plus 28a minus 64 equals to 0. Dividing the equation by 2, this will become a squared plus 14a minus 32 is equals to 0. So factorizing this, so we have to get minus 32 when we multiply and 14 when we add. So we can get a plus 16 and a minus 2. So this will be a plus 16 and a minus 2 equals to 0. Now we have two values of a over here and we have to find the value of a, and it is saying where a is a positive constant. So as we have two values of a over here, a minus 16 and a is equals to 2. So the only value of 2 will be positive. The only value of a will be positive 2. Now, once we have the value of a, we know that the coordinates of a are a squared and 3. So that will become 2 squared, which is 4 and 3. And the coordinates of b are, so coordinates of b were given as 16 and 8. And the last part, we also had to find the distance AB. So the distance AB will be given by the formula x2 minus x1 whole squared. So that will become 16 minus 4 whole squared plus 8 minus 3 whole squared, which is equals to, so 16 minus 4 is 12. 12 squared will become 144. 8 minus 3 is 5. So 5 squared is 120 is 25. Adding these two, we'll get 169. So the distance AB will be equals to positive 13.